welcome back. So let's move on to the next sections. So here another method that we can create tensors is using torch as tensor. So actually these are methods that we can output a tensor. So the first one was just adding, let's as a kind of recap from the previous section, we can input an array, or we can use a NumPy array. Already we created it. Here is another method that we can use it as a tensor or an array as a tensor. So to do that, we can say that as tensor equals torch dot as tensor, and here we can pass an array. So 1, 2, 3, and 4, 5, 6, and let's print it out. Print as tensor. Again, we have a tensor. We already saw the from NumPy one method that we just input a NumPy array inside a tensor here, but also we can use a method called from NumPy. So let's from np, and let's first create an array. So an array could be np.array, and let's call it like 10, 11, 12, and 6, 7, 8. And then we can create a tensor from NumPy. This is another method, torch.from NumPy, and here we can pass array. Now let's print from np. Again, we can have a tensor from NumPy. So this is good to know that we can create a tensor from an array with different methods. Another method that we can create tensors is using zeros, ones, or I, which is identity matrix, which we explain it one by one. So let's create zeros tensor. To do that, let's say zeros equals torch dot zeros, and here we need a size, so let's call it 3 by 3, and let's print it. Print 0, and here zeros. Okay, so it creates a matrix, a 3 by 3 matrix that all the elements are zeros. The same we can do for ones. So ones, torch dot ones, 3 by 3, and print ones. Here we have a 3 3 rows and 3 columns matrix that each element of that matrix is 1. And the identity matrix in Torch with we can use it like this, torch.I, and here we can pass the shape. Now let's print it. Print identity matrix. Here we have a matrix 3 by 3 that the elements of on the diagonal of this matrix are 1. Another method that we can use to create a tensor is using an empty tensor. So it creates it's a kind of an object that it has a data holder. So it creates an empty, it defines a space in memory that's with the size that we already defined for that, but it doesn't have any values in that. So for that, let's create an empty matrix, torch.empty, and 3 by 3, and print it empty. So you can see there are some garbage numbers that it doesn't define anything. It's just some let's say areas in memory that we can define, and then we can fill any element with the numbers that we need in our program. Another method to create a tensor is full. So basically, full is a method that we can use to create a tensor that filled by a value. So let's try it. Full equals torch.full, and here we need a size or a shape for that matrix and also a value. So for size, we need to pass it in a tuple. So let's say we want to create a 3 by 4 matrix, and for value, let's say we want to have a matrix of that has 100 as each value. So let's print it full. So now we have a 3 by 4 matrix that each value is 100. Another method that we can create a tensor is torch.diag. This is very similar to the I tensor that we already saw, but it adds different elements to that diag of the matrix. So for that, we need to define an array or a tensor. So let's say diag elements could be torch.tensor, and let's say 15. Let's make it as float 15, 10.8, and 20.9. And now we can create our matrix, that torch dot diag, and we can pass this tensor, and now if we print it, we can see it puts each of these elements as the diagonal of this tensor. Another method or methods that we can use to create tensors are these three, let's say, sequential functions. So arange is pretty, and linspace and also logspace are pretty similar to NumPy, but let's give them a try. So arange, let's say we can say torch dot arange, and here we can say that if we need a start for that, 0. We need an endpoint for that, here let's say 10, and we need step number that we want to create between 0 to 10, let's say 0.5, and let's print it. So now you can see that it creates a sequence from 0 to 10, which the step size between each element is 0.5. So basically it doesn't, it includes the first element, but it definitely doesn't include the last element. And for linspace, let's say lin equals torch dot linspace. So for that, the same signature as arange. We need a start number, so let's say 0. We need an end number, which we can say 10, and we can say step, which defines the step of that. We can also say steps equals 5. And now if we print it, lin, so it has 5, it defines 5 numbers between 0 to 10. So 0, 2.5, 5, 7.5, and 10. Very simple but useful. Another one is logspace, which it creates a tensor of logarithmic space between start point and end point. So to do that, we can create it as torch dot logspace, and the same signature. We need a start point 0, and we need an end point, let's say 10, and we need a step size. We can write steps, or we cannot, it doesn't matter, but it's good to write it, so we already know that when we go back to check our code. And let's print it, log, Okay, so it defines 3 numbers between 0 and 10 in a logarithmic format. Okay, so thank you for watching this tutorial. We will continue to the next sections in the next tutorial. Thank you.